Step into the Coliseum, everyone. Welcome to this extended, deep dive explainer. Today, we're stepping into the absolute ultimate arena, the Cambridge Computer Science exams. Only the prepared survive in this arena. Whether you're tackling syllabus 0478, 0417, 2210, or even A-level 9618, the strategy we are unpacking today is your absolute lifeline. We are mastering the binary and denary method, but we are doing it by moving far, far beyond basic rote memorization. Now, I want you to picture a dynamic split screen in your mind right now. Over on the left side, we've got a student named Alex. Alex is the kind of student who overloads every single answer with raw computer science facts, literally dumping everything they know onto the page with zero analysis. Then on the right side, we have Sam. Sam rushes. Sam completely misses the command word requirements of the question and just rates whatever comes to mind first. So what do Alex and Sam actually have in common? Well, they both leave that exam hall feeling incredibly confident, and a few months later, they both end up staring at a results page, wondering why they got red pen marks all over their flawed answers. Today, we're going to fix that. We're going to transform those red marks into green check marks. Let's dive right in. So, here is the absolutely crucial question we have to start with. Why do students, and honestly, maybe even you at some point, know the vocabulary perfectly, but still lose those precious, precious exam marks? It is the ultimate frustration, right? You sit down, you open the paper, you see a familiar word. You think, binary, oh man, denary, I know this stuff backwards. But here is exactly where the trap snaps shut. As our source material points out, in computer science exams, so many avoidable losses of marks happen because candidates recognize a familiar word, get excited, and then answer a completely different question from the one that was actually sitting right there on the page. Alex and Sam fell for this completely. They saw a keyword, their brains just automatically fired off a memorized vocabulary list, and they completely missed the actual digital problem they were being asked to solve. They lost marks not because they didn't know the facts, they knew the facts, but because they didn't know how to actually use them. All right, here is our roadmap for today's explainer. We've got 6 key areas. Number 1, moving beyond rote memorization. Number 2, the 3 layers of a perfect answer. Number 3, the battle of describe versus explain. Number 4, the worked process. Number 5, avoiding common errors. And finally, number 6, a brilliant 4-question self-check to make sure you're ready. Let's get to it.
Starting off with Section 1, Beyond Rote Memorization. The golden rule here is simple. Context is everything. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, look at this. Always start with a digital problem, not a vocabulary list. Binary and denary number systems, or honestly, literally any topic in the data representation chapter, cannot be learned in a vacuum. If you were just sitting there memorizing definitions on flashcards, you were setting yourself up to be Alex, just dumping facts without any analysis. The theory only matters when it is applied to a specific context. Before you even look at a textbook definition, you need to stop and ask yourself, what problem does this concept actually solve? What kind of data or device is involved here? What is the practical consequence for a user, a system, or an entire organization? Our source data is incredibly clear on this point. Students retain the topic so much better when they understand the reason for the concept's existence in the first place. If you understand the digital problem, let's say how a computer processes hardware limits or transmits data across a network, the vocabulary naturally locks right into place without you having to force it.
You see, binary belongs to a much larger web of ideas. You absolutely have to be able to distinguish between similar-sounding terms and focus on the practical consequences. The theoretical foundations usually depend on really important distinctions. Our source highlights these massive contrasts that you just must know instantly. I'm talking about memory versus storage, data versus information, protocol versus service, compiler versus interpreter, validation versus verification, and physical security versus logical security. Computer science reasoning becomes vastly, vastly stronger once these boundaries are totally understood. Recognizing these connections prevents you from falling into that trap of answering the wrong question entirely.
Moving right along to Section 2, the 3 layers, building the perfect answer. Now this is where we transition from merely understanding a concept in your head to actually decoding the command words on the paper and structuring a top-tier response that the Cambridge examiners absolutely love. This is the transformation phase, guys. Our source material outlines an ideal walkthrough for any concept, moving through 3 distinct layers. Step 1, the simple explanation using everyday language. Explaining it like you would to a friend. Step 2, the technical explanation, injecting the correct subject vocabulary. But step 3 is the magic one,
the exam explanation, shaped into a response that scores maximum marks under intense time pressure. This is where top students really shine. They decode the command word and apply a rigid framework. Think of it like the Peel framework, point, evidence, explanation, link. Students often mistakenly think they know a topic when they've only reached layer 2. They've got the vocab down. But layer 3 is where the marks are actually awarded. You have to translate your technical knowledge into a structured, exam-ready response using Peel to guarantee you hit every mark scheme requirement.
Welcome to Section 3, Describe versus Explain. This is what we call the critical boundary.
There is such a powerful separator between average grades and top-tier grades in computer science reasoning, and it all comes down to command words. Let's look closely at the difference between describe and explain. Describe simply tells the examiner what the device, process, or method is. You're just giving them the surface-level facts. Explaining, on the other hand, tells the examiner exactly how it works and why it actually matters. In the higher mark questions, examiners usually expect both. If you only describe, like our student Alex, your answer sounds safe, but it's totally shallow. You will not get full marks, no way. But if you just jump straight into explaining without clearly naming or describing the concept first, like our Russian student Sam, your response sounds confused and incomplete. You absolutely must bridge this boundary to succeed. Decode the command word first.
And as this powerful quote straight from our source material states, generic responses rarely gain full marks. Floating abstractions fail in the exam hall. Period. If the question specifically asks you about a retail environment, your answer cannot just be about binary theory in general. It must be explicitly about binary in that specific retail system. If you give a textbook definition when they gave you a scenario, you are leaving marks on the table.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's jump straight into Section 4, the worked process, a disciplined path.
Let's completely break down the tactical, step-by-step process for executing an answer when that exam clock is aggressively ticking down. Here is your ultimate blueprint for success. Step 1. Identify the demand of the question. You have to decode the command word. Are they asking for hardware selection, program design, or evaluating alternatives? Step 2. Classify the correct concept. Don't jump to the first buzzword that comes to mind. Step 3. Explain the sequence or structure step by step. Remember, so many computer science topics are purely process-based, so logical order is literally everything. Step 4. Connect the explanation back to the context, and check if you need to add an advantage, disadvantage, or a comparison. Apply that PEL framework we talked about. This 4-step structure creates a beautifully clear, high-scoring answer, which is just vastly superior to blindly writing facts in a random order.
Let's look a bit closer at that final step, contextual connection. The definition we are using here is applying the technical concept to a real-world scenario, like a school, office, or retail environment. Okay, let's do a quick interactive workshop right now. I want you to imagine a really complex data table on the screen in front of you, showing network speeds in a super busy hospital. You've got 60 seconds. Your brain needs to scan that data, identify the core trend, and then force your technical knowledge of binary data transmission specifically into the context of that hospital's patient record system. Real-world transfer matters immensely because it converts raw memory into usefulness. The patterns behind these systems appear in your mobile phones, in banking systems, robotics, and school management tools. If you can actively connect the topic to familiar technology, you will naturally remember the exact reason the concept exists, not just its label.
Let's move into Section 5, Avoiding Common Exam Errors. Don't fall for the traps.
Time to shift our focus to the predictable, annoying pitfalls that examiners see over and over and over again. Vague wording, confusing similar terms, missing sequence steps, ignoring the given context, or, my personal favorite, stating an advantage with absolutely no reason, or identifying a device without justifying it. Let's do another quick challenge. Find the flaw. If I show you a sample paragraph right now that just says, "The system uses binary because it is faster," you should instantly spot the flaw. Boom, right there. It states an advantage with zero reason and zero context. Why is it faster? How does it apply to the scenario? This is exactly why error-aware study notes are vastly superior to notes containing only correct facts. You need to know exactly how not to answer. In process-based topics, jumping forwards and backwards completely breaks the flow. Explain the mechanism first, then state the consequence. Take a second right now to imagine structuring a perfect Peel paragraph in your head, purposefully dodging all of these traps.
Surface features like a keyword or device name can massively distract you from the real process. I really want to warn you strongly here. Do not fixate on familiar symbols at the expense of actually understanding the core mechanism. If you see the word router in a question and you just immediately write down a generic textbook definition of a router, you might completely miss that the question was actually asking about logical security configurations on that specific device in a corporate network. Keep returning to the core mechanism. Okay, speed writing challenge time. I want you to imagine a 30-second timer counting down right now. Can you mentally draft one perfect Peel paragraph about why a router uses binary routing tables? Go! Point, evidence, explanation, link. It's tough under pressure, right? That's why we practice this structure.
And finally, Section 6, the final self-check, the 4-question diagnostic.
This right here is the ultimate undefeated revision tool to guarantee you are 100% exam ready. These 4 diagnostic questions are your absolute gold standard. Before you close your books at the end of a study session, you must be able to answer these aloud for every single concept. 1. What is it? 2. How does it actually work? 3. Where is it used in the real world? 4. Why is it better or worse than the alternative in that specific situation? If you can answer those 4 prompts aloud clearly, the topic is absolutely ready for the examination. If not, don't fool yourself. You need another cycle of reading, explanation, and active recall.
True adaptability, not just memorized wording, is the real key to exam survival. If a concept can be paraphrased accurately, it will survive the pressure of the exam hall. A high-quality revision cycle involves multiple passes, constantly changing the context, mixing nearby terms, and aggressively forcing yourself to justify your choices. Listen, students who implement these computer science strategies see an average improvement of 2 full grade boundaries. Let that sink in, but that is only if they practice consistently with our weekly videos and actually apply the frameworks. So, I will leave you with this final, provocative thought to carry into your next study session. Are you just memorizing binary? Or are you truly, genuinely ready to use it? Step into the arena, use the framework we covered today, and take absolute control of your results. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel on your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Also, drop a comment below right now with your target grade for computer science and the biggest challenge you're currently facing. Our team literally responds to every single comment. Give this video a like, share it with your study partner, and remember, Ace the Exams, your Cambridge success starts here. Keep analyzing, keep questioning, and keep focused on the context. See you in the next one.